Waves and pulses. The effect of a single vibration traveling through a medium is called a pulse. Now, in this case, we have our medium, which is the rope, and we're then going to allow a pulse to travel through it. We then get amplitude. So amplitude is the maximum displacement of a particle from its rest position. So if we look at this, that green particle there, that is the greatest displacement that it moved away from the normal position. Then we get pulse length. So pulse length is a measurement of how long the pulse is. In this case, we're going to get 3 different examples. So let's say we've got a 0.5 centimeter pulse, then a 1 centimeter pulse, and then following that, we get a 2 centimeter long pulse. And so pulse length is just how long that wave is from the start to the end. Now, all of these that we've been looking at are transverse pulses. This is because the particles move at right angles to the forward direction of motion. So if you look at that, you can see then the wave is moving in that direction and the particles are moving up and down. Then we get to superposition. Now, superposition occurs when 2 pulses meet to occupy the same space at the same time. The pulses combined and the resultant displacement is the sum of the displacements of the individual pulses. So let's look at examples. Now in this case, we have 2 pulses. Let's say that this one has an amplitude of 2 and this one also has an amplitude of 2. When they meet, we can see then that they get a much greater amplitude. In this case, they would add up to give us an amplitude of 4. And we can see that then both waves carry on in the direction that they were moving before. We also get superposition when 2 pulses don't have the same amplitude. So let's say this one has an amplitude of 2 and this one now only has an amplitude of 1. When they meet up, we see then that they'll add up to give us an amplitude of 3. And they both continue moving in the direction that they were moving before. We then get destructive interference. Now, destructive interference is when 2 waves meet, but the resulting amplitude is going to be less. So if we've got an amplitude of 1 there and an amplitude of 1 there, and we get it to go, we can see then that when they meet up, the amplitude becomes 0. We can also look at this when it's unequal. And so if we have an amplitude of 1 there and an amplitude of 2 on that one, when they meet up, let's try that again. When they meet up, we see that we get a slightly less of an amplitude, and we get the greater one going back there and the smaller one carrying on at that position. Right, join us next time where we'll look at transverse waves.